Okay, so we're going to have a look at sequences, right? Patterns of numbers. So let me ask you one thing. What are you expected to be able to do with patterns or sequences of numbers? Find the pattern. What do you mean by find the patterns? Okay. So I'll say describe the pattern. Okay. So like saying that could be it goes up by an amount, it goes down by an amount, or so on. So what are the options for patterns? What can it go up by, down? What are the options for creating a sequence? What can we do? We can add an amount, we can subtract an amount, we can times, or we can divide. Now I would actually say that there are only two. Which two out of those four are we actually using? I'll give you addition and multiplication. Why only those two? Because obviously a sequence can go down because you subtract. I will say that is actually addition. Addition of a negative. So actually a subtraction is we're adding a negative number. Right? And division is multiplication by, could be a decimal, I'm thinking of a fraction. So 1 over k. So for instance, if I wanted to add 3, I can just add 3. If I wanted to subtract 7 every time, I would actually add -7. Okay. If I wanted to times by 2, fine, I just multiply by 2. If I wanted to divide by 3 every time, I would actually multiply by
3.
So go on then, what's the same as dividing by 3? I was just having this chat with one of my M2s. I want to divide by, actually we have in the opposite order though. What's the same as dividing by 3? Multiplying by a third. Yeah. Multiply by a third, you get the same answer as divide by 3. So when we're dealing with our sequences, we don't tend to subtract and we don't tend to divide. We still add, but we add a negative, or we multiply by fractions or decimals, if you want to put it that way. So that's how we do things. And that way we can generalize our rules, we can generalize our patterns without having it overcomplicated. Now, if our pattern is formed by adding a constant amount, whether it be a positive or a negative, what kind of sequence is created? Do you remember the name? It's an arithmetic. That would be an arithmetic sequence. And if it is formed by repeatedly multiplying by something, someone else in the time is going to get one out. Anyone remember? This was your strongest. Geometric. So this would be a geometric sequence. Right. We do have another set of sequences which are not always add the same amount. And what would that lead us to? Well, we had quadratic sequences. And do you remember what would form a quadratic sequence? How would you know it was a quadratic? So how would you sum that up for that first line of difference? It's not always add 3 or add, what is it? Whatever you add on. You go a step further than I mean. How would I know it's going to be quadratic? Because in the first line of difference it's going to be not the same. It'll be changing, yeah? So for a quadratic sequence, it's not always add 3. It would be add 1, then add 3, then add 5. Then. So if that happens, remember that would be the first line of difference, and then you start looking at, well, that's then add 2 every time. That would lead us to think it was a quadratic sequence. Right, so you've got the different types of sequences. So you have to be able to identify them. Right. What are you then expected to be able to do? Find a rule, okay. So you are then expected to be able to find the general rule. Now ask why. What is the purpose of finding a general rule?
So you can find out like future
terms. Yeah, definitely you can find out future terms. All right? Not necessarily even future terms, you can find out any term. And why might that be a useful skill to be able to do?
Well, a lot of their questions will have stuff like that involved.
Like, give me a specific example of where you would want to be able to find a specific term. You might have to find a way these things are applied.
Like that car question we had a little bit ago, and the value of the car decreased X amount over the years.
Exactly, yeah.
What was the value of the car using X amount?
Yeah, definitely. Yeah.
finding 200 terms.
Yeah, but why would I want to? So like he's given it an application, can you think of why would I want to find the 200th term in the sequence? So what could be what is that sequence for, I guess is what I'm asking for. Because we're moving away from just, it's a list of numbers. Who cares? You've got a list of numbers. But these days, you know, you're talking about moving into selling cars, you know, you insuring cars, whatever. If you're going to work in insurance, the whole point is you need to work out what you think this car is going to be worth in 5 years' time. All right? So we want a model that does it. So we're actually talking more mathematical modelling here. So like Bradley said, I want to be able to predict what that car is worth in 10 years' time. So have you got any other options for how these sequences can be applied? Yeah. So you'd be in a bank, you deposit some money, how much is that going to be worth in 25 years' time? Or you take a loan out, what are you going to owe back in 25 years' time? Yeah?
Could it be like the amount of something, like population growth?
Yeah, definitely.
How oil and stuff that we're gonna have?
Yeah, exactly. If you're looking at how something is changing over time and you want to be able to predict, you know, like say population growth, if you can work out that that is a geometric sequence of numbers, then you want to be able to predict. If we think of it in a different way, maybe we don't want to know just the 200th term. Maybe we want to know which term the amount goes above a certain level. Why might we want to know that?
Because if you're budgeting something,
Yeah.
you have like a certain amount of hours worth of, like if you're going to a construction site, you have X amount of money. You can only pay people so many hours to do the work. You have to budget like how many hours that you have the money to
Yes, exactly.
pay for
Yeah.
the work.
If you know you've got $100,000 to spend and you know these are your outgoings, then you've got to cap it at a certain level. You know when things have to be done. So you work out. So we have all these sequences of numbers. they're not just lists of random numbers. In your reassessment, they're going to be applied to something, and there's a whole wide range. But what is the general topic? It's normally something to do with money, finance of some way, isn't it? The value of a car, the amount of money in your bank, the interest paid on a loan. Okay, what's another normal topic? We've already said it once. That's the finance stuff. Bradley mentioned it. Population. So you've got population growth and decline. Are there any chemists or physicists in here? Anyone know about radioactive material and their half-life? Yeah. How long it takes for a particular radioactive isotope to reach a level where it's safe to go, you know, that kind of thing. How do they know that there's a little series coming out on TV, I think, called Chernobyl, about the disaster of that, and how do they know when it's safe to go back to that factory or that reactor? Well, they're talking thousands of years, and the only reason they know that is because they know how much the radioactive half-life of that material is, and they can then predict how long it will take to reach a safe level. So that's why we've got these sequences. So you are finding these rules so that you can make these kind of predictions. All right, so this is why we do it. So let's take each one in turn then, and let's see whether you can remember how do you find the rule. All right? So let's take an arithmetic sequence. Anyone know another name for an arithmetic sequence? It's to do with its behaviour, if you were to graph it. It's linear, yeah? So this will produce a linear function. That's because we have a constant change. All right? It's also called a common difference. Remember that? So an arithmetic sequence. Paris, give me an arithmetic sequence. Anything you like. So you're just going to pick a starting number and then add the same amount on every time. Give me the first 6 terms. I'm going to go for 5, just to make it a little bit harder for us. What's the next number? 8, 11, 14, 17. Okay. So, how do you find the general rule of this? Yep. Go on then, what is that?
So
there's always plus 3. Okay. So my common difference D is 3. Now what do I do? There's 2 ways. There's the long way, there's the shortcut way. You use whichever one suits you. If you remember your straight line graphs and things, and you make the link with linear functions, maybe that will help you. Yeah? Go on then. 3n minus 1. Yeah? Would you like to explain where that came from?
I just recognize that it went up by 3 each time.
Yeah.
And since 2 is the first term, 3 times 1 is 3. It will be minus 1, so it's the first term.
So do you all remember that if it's plus 3 every time, you just say 3n? That's kind of the shortcut approach. Do you all remember that? If it was plus 5 every time, it's 5n. What it's not is n plus 3, which is what a lot of people do by mistake. They say n plus 3. It's 3n, and then as Tyler said, the first term, so n being 1, I need 2. So I do 3 times 1 actually gives me 3 times 1 actually gives me, oh, good, I'm so glad you were just not, because that would have been hard to take. But I actually need 2, so I have to subtract the 1, okay? And then I check that it works, so when n is 2, I need 5, so 3 times 2 is 6, I need to subtract 1 to get 5, I'm sorted. Alright, so that's my rule. So if that's the way you remember it, fine. Is there anyone that remembers it a different way? So you've got a formula booklet with this in. So another, which, are you all happy with it that way? Shall I move on? So if I said to you, we've got 5, 9, 13, 17, 21. Carl, would you like to go for this one? Would be 4n plus 1. All happy with that? Yeah. So that's arithmetic sequences. So what the next stage would be is if I said to you for this particular sequence, what is the 101st term? What would you do?
101 times 4.
Yeah, so I'm going to do 4 times 101 plus 1, and I get, the answer is 405. Okay? The next kind of question would be, is 728 a term in this sequence? Justify your answer.
So would you do minus 1 and then divide by 4?
So what would I set up first? So let's say I have to justify my answer. What are you showing? So you first write
728 minus 1.
I wouldn't do that yet. I'd actually write down something else first.
728 divided by 4.
Not yet. I haven't written something down. I want to make a statement first. I'm saying that this here, I'm asking, does 4n plus 1 ever equal 728? Yeah? That makes sense? So I'm saying, is 728 a term in the sequence? So that would be, and how would I know if it is or not? Good. Is that what you're going to say, Matthew? What were you going to say? So if this is, if I work this out, if I solve for n, and n is a whole number, so n has to be an integer. Do you remember that notation? Alright? I can make that statement if I'm in my exam. If it's not a term. So what do I do first then? I think you were trying to do it. So 4n equals, so subtract the 1 first, we get, then we have n equals, which is, do I can work it out, but I know it's not going to be a whole number, right? What have we got? 181.7. Okay, so the answer is no. Could I ask you to come up with an application of this? Doesn't need to be too exciting. Could I come up with a question where this is applied to a situation? Think finance, whatever. It doesn't have to be too realistic with numbers, but like a question like this. Anyone, any ideas? So we've got a rule, 4n plus 1. can even use this situation. Well, how about this one? Go on.
Maybe how long it takes to reach this.
Yeah, what could, yeah, I was going to go with that, but what could the actual situation be again?
How long it takes to reach 728.
But what's your actual real world scenario?
How long or how many years does it take a company to reach
Yeah, same idea, just with a, so how many years would it take this company to reach $728? Pretty rubbish company. How long did it take them?
Wow.
But as soon as we put it in this situation, what changes? We've got to take into consideration the accuracy at which we've got. So if we were to say it takes them 181 years, or 181.7 years, have we reached that amount of money after 181 years?
No.
No, not quite, because we need 181.7, yeah? Do we get our money halfway through a year, or do we have to wait till the end of a year? Potentially we have to wait. So if I know the situation is that actually I have to wait till the end of the year to get the money, how long does it take? 182 years. So even though I've got an answer of 181.7, which in just purely mathematical sense is not a term in the sequence, if I do it every year, if I put it in this context, I can suddenly say 181.7 makes sense, but I've got to go one after. So the company will never get exactly $728, but I want to know when I've got at least $728. Does that make sense? So that's how you can apply it. So we're actually looking for, sorry, if I take Kenzie's example, I'm no longer solving 4n plus 1 equals 728. What am I actually doing? I'm saying when 4n plus 1 is greater than or equal to. So I'm using my inequalities. So I can write that. So because of the situation she gave us, I can now start writing that. Doesn't change what I do mathematically, but that's it. All right. Any further questions on that one then? Should we move on to geometric? Are you ready to move on, or do you want to make some notes? We've talked about saying that when it's a sequence of numbers, n always starts at 1, and then we do 2 and 3. Does it make any sense? So the first term would be, for this one, 5, and then it would be 9, and then it would be 13, and so on. Does it make any sense to actually start at n being 0? 1, 2, 3. So that means that the first term, the second term, the third term. So why would it make sense to have a 0 for n? Any ideas? Again, it's back to this, how these sequences apply. So when could I have an n being 0? So let's say I give you some different answers. Say this would be 10,000, this would be 9,000, 8,000, 7,000. So give me a situation in words where that sequence of numbers. So now I've got a 0th term, not the first term. N being 1 is normally the first term, but actually now 0 is the first term. So now I've got a different meaning for that 0 and 1. So what could it mean? Yeah?
Perhaps the car after when you first buy it for $10,000 and appreciates it after 1 year.
Exactly. right? So again, in financial sense, right, in financial terms, when n is 0 means no time has passed. So that's its initial value. And you quite often have that with bacterial growth and populations and things like that. You'll have a 0 for n. And that's what it is initially, before any time has passed. So the 1 is not just the first term, it is an actual 1 minute has passed, or 1 month has passed, or 1 year has passed. So 1 year actually means second term. So you've got to be aware of that. All right? So we have got to be aware of the situation. All right, let's just move on quickly to our geometric sequences. That means we can probably talk about quadratic next time, tomorrow. So what's the difference between in a geometric sequence then? So Matthew, would you like to give me a geometric sequence?
You can have.
I'll start you with 1.
Okay.
1 then.
And then 1.
Oh, you have 1.
I have 5.
5, okay. Then
25.
it would be 25.
Okay.
Then it would be. Go on then, you've got one, you've been on it for. Anyone want to say it straight away? 125. So the next one would be 625. No. So how do I make this geometric sequence? I actually times by 5, multiply by 5 every time. Okay. Can anyone remember therefore how to do the general rule for this?
Is it 1 times 5 to the power of 1 table 1?
Make sense?
Yes.
Okay. Do you all remember how to do that one? Yeah? You remember doing that? This one specifically, again, or actually let me ask you this one. So let's go with 10,000. The next term will be 5,000. The next term will be 2,500. The next term will be, yeah, next one, 625. And we'll stop there. Okay? Can anyone tell me the general rule for that one? Okay, so what's the first bit? So that was 1 times 5. So this one will be times a half to the power of, yeah? So that's why I said there's no divide. The general rule does not have a divide by 2. It has a times by a half. Okay? Now, that's just as a general list of numbers, but what, again, what could that be as an applied problem? Yeah, situation, same one as we were talking last time. Frankie, stay with me. Not long left. What could it be? Same situation as before? Car. Okay.
Depreciates in value.
Depreciate. Now, if I ask you then for a formula that tells me the cost, the value of the car after a certain number of years, how would that change this formula? Or would it? Would it not change it? So, for instance, what would be the value after 4 years? So we do have it. The value after 4 years is 625. Let's say dollars. Okay. Let's see whether we can get that. Because it is that.
Oh, because the first year is.
Yes, exactly. So let's just see. What do we do then? We do 10,000 times a half to the power of what? Do I do 4 minus 1, yeah? Right, what's that answer? If you do that on your calculator, please. So that's 10,000 times 1/2 to the power of 3. What do you get? Do you get $625? You get $1,250. So what's gone wrong?
Value more than
So what's gone wrong? Where's the problem? It's 4 years. Isn't n the number of the term? I've got n minus 1. So where's the problem? See, I'm assuming that 4 years is the 4th term, but it's not, is it? It's the 5th term, because what is the first term? It's not term number 1 again, it's term number... No. 0 again. In financial, remember this is where the application thing, this is the 0 term. The first,
Sounds like the ground.
that's my initial point. It's the first term in the sequence, but it's after 1 year. So what's important for you to realise is this, for the n minus 1, gives you a particular term, right? So if I want the 4th term, I put in n minus 1, do 3. But when it's a financial sense, actually what we do is we change it a bit and we want 10,000 times a half to the power of n, not n minus 1, because the first term is actually 0 years, and that's where you have to take that into consideration. So that's where it could be a nice simple question and you're just fashion way, you've done it, you've typed it all in, but you could be a whole year out because you forget that, you know, year 0, year 0 is the initial point. Okay, so you've got to take that into consideration. And this is really common with financial maths. Okay, any questions? So what kind of questions could again I ask you for this? Come up with a couple of just verbal questions for me. How to change it. I'm an e-assessment exam writer, I'm writing you some questions, what could I change it to? Yeah, could do that. That would just change the context. No, it's fine, I didn't specify. Now I'm going to specify, could you keep the same context but rewrite it so I'm asking you to do different maths? Same sequence and stuff. So this was asking you to find a particular term. We've already had this discussion with the previous sequences, so it would be again... Well, we've got a car that's bought for 10,000. How could you write a question? Part B is, over to you. So the value of a car is modelled by this function. You know, how much is the car worth after 4 years? Part A. Part B. Done that. Same thing as we did with the arithmetic sequences.
The numbers probably don't work, but what year would it be worth?
Yeah. After how many years would the car only be worth $5? Yeah. The minimum value of the car would be $2,000 and you want to get rid of it. How long do you keep the car? that kind of thing, yeah? Do you get the difference? So that's what we've got with our sequence. We'll talk quadratics tomorrow, unless you've got something to do.